So I want to now move on to the final stage of the build of the PA and the low pass filters. So the PA, as we sort of went through before, consists of this pair of RD15 HVF1s. And then we have these this feedback arrangement here with these two 220 ohm resistors, this capacitor here, and then that goes through this one-to-one-to-one wrapped on a BN43202 binocular core. There's also some supply circuitry up here, some filtering circuitry here. These consists of some 18 gauge wire with some ferrite beads on them, and I'll show that as I build it up. These are all SMD caps here. And then finally, I've got another toroid to wind here. This is a 1-turn to 2-turn final output transformer. There's a 270 picofarad cap that I've got to also install. So before we dive into that, I just want to do a quick note on these RDF15 HVF1s. And there are fakes everywhere. I've got a kind of simple test to at least determine if it is definitely a fake. Just for the purposes, this is the fake and this is the real deal. I got this off RF Parts. There's a few other suppliers out there that you can trust for real parts. RF Parts is one of them. So this is the real one. This is the fake one. Let's just get this on a transistor tester and see the differences between them. Okay, so I've got the fake RD15 here, and you can see from left to right, it goes gate, then the green one is the drain, and then the red one is source. So this is a similar pinout to the IRF 510s, but it's actually the wrong pinout for an RD15 HVF1. So the correct pinout is it goes gate, source, and then drain. So let's put the real RD15 on there and see the difference. Okay, so I've got the real one in there. Let's run the tester again so you can see that. And you can see there, so red is the source, so you can see that's the middle pin is the source. Blue is the gate, and green is the drain. So this is the correct pinout for the RD15 HVF1. And incidentally, it's the correct pinout for the RD16 HH. I can't remember the last two characters in that, but these are two sort of popular MOSFETs that you'll see in the final stages of some sort of ham radios and some CBs. But this is the real deal. Now, what I've got here is, and if I could just pan onto the circuit here, I do have a pair of these fakes installed because I just want to see. I want to actually compare the difference. So I'll run with these fakes installed. I've got a sort of a heat sink here ready to go. And if you'll note, I've had to cross over the leads again because the PCB is expecting gate, source, drain, and the MOSFET is gate, drain, source. So I've just had to cross them over and I've confirmed they're not touching. So what I'll do is I'll move on to building up the toroids. I'll walk through how they're wound, and then we'll come back and kind of build the remainder of the circuit and test it up. But let's move on to the toroids now. So just to summarize the difference, on the left, this is the pinout of what I feel is definitely the fakes. And then on the right-hand side, the pinout of, well, it's maybe okay. You don't know that it's definitely a genuine article, but if you've got this gate, drain, source pinout, then my assumption is this is not a real RD15 HVF1. If you have a gate, source, drain pinout, then at least it matches the Mitsubishi pinout that is in the datasheet. So maybe it's okay. But anyway, not definitive. I mean, you'll see there's piles of these on eBay, the RD15, the RD16s, and they all, I've actually bought a few of them. They all have this gate, drain, source pinout. I had to acquire these ones from RF Parts, and I'm assuming from RF Parts they're going to be genuine. Okay, so here's the one-to-one-to-one wound on the BN43202 binocular. And you can see, so just to sort of go through the windings, so these two are in common. These two at the ends are in common, and these two are in common here. And that's pretty much how it goes on the board. You do have to make sure, of course, that there's no I get a bit of focus here, that there's no touching of the windings here, and I'll confirm that, but you can also confirm it once it's in circuit as well. So I'll get that installed, and then we'll come back and test that all the continuity is right. Okay, so there's the core placed in the board, but not soldered in yet. And as you can see, so just to go through again, so these two windings are a pair. These two out either end of the core are a pair, and then finally these two windings here are a pair. So let me get that soldered in, and then we'll test continuity. Okay, I've just realized that once it's in circuit, you can't really test continuity because these two windings are connected together. Once it's in the circuit. So what I can confirm though is that this winding doesn't have any connectivity with these two windings here. So let me go ahead and do that. Okay, let's just test continuity. And as I said, so here's those four windings on the two windings on the output side, and they all have continuity with each other. But these two windings here on the outside, so there should be continuity there, and no continuity to the windings on the other side. Now, unfortunately, there's continuity across all of here, so I can't really test whether I've accidentally short-circuited these here. But you can see there's plenty of enamel on the remaining on those two windings there. So I'm pretty confident that this guy's installed correctly. Let's move on to the bigger binocular core, which goes right here now. Okay, so here's the output transformer here, and you can see it's on a BN433312, which is, let me see if I can get it in focus here, which is this fairly hefty binocular right here. And you can see it consists of two turns on the output side, and then there's a single turn on the input side, center tapped. So let's just go down to see that here. So I've created, here's my single turn center tapped. Now I'm doing this a bit different to the way the instructions say. So I'm doing this at my own risk. The instructions go through a method where they use coax. I just didn't have any kind of that coax to hand, so I think it was RG413 or something they wanted. But anyway, I didn't have any, so I thought I'd just use this. As you can see, this is that single turn on the input side, and I've just simply soldered a center tap right here, and then that goes into the toroid, the binocular core, sorry, like so. So these three windings, these three endpoints here are all the input side, and then for the other side, you just simply wind the two turns around there. So what I'll do is I'll get that installed, and I'll get that set up, and then we'll come back. So here's the finished product, tinned and ready to be installed. So this is the input windings here, and here, and then this is the center tap on the input windings, and then here's the output windings here and here, two turns. So what I'll do is I'll just make sure there's no continuity between any of these three. Well, make sure there's continuity between here and these two, but no continuity to the secondary. So let me come back and do that. Okay, so let's first check the input windings. So here and here. So that's continuity between the two input windings and the center tap. Should be no continuity here. You can see that. And then there should be finally continuity between these two. And there is, so it's ready to be installed. Okay, so here's the core installed, and let's just check continuity again. Do this behind the camera. So there should be continuity between here and here. And there should be no continuity to anything on this side. Oop. Pardon me while I do this. All right, so you can see that. And there should be continuity on the input side. All three, bear with me, I'm just got to sneak that in there. Okay. Okay, so I've installed all the caps associated with the supply filtering, and what remains to be installed is L42 and L1. And what they are is basically ferrite beads. Let me just zoom in. Ferrite beads are put on some 20 gauge wire. So you can see them. I've got them put in place there. I'm going to strip the enamel off here and get those both installed and come back. Okay, so there's the ferrites installed, and I've tested continuity between here and here, and all is good. So that's the power supply filtering to the MOSFETs all installed and good. What I need to do now is, just turning the board over, is install, so this is where the 220 ohm resistors go, here and here. And then there's a pair of 0.1 microfarad caps here and here. And then finally there's a 220 picofarad, I believe, 270 picofarad capacitor that goes across the the input winding of the output transformer. And that's pretty much it. I'll do a sort of a once over on the board, and then we'll probably be ready for some testing. Okay, so everything's pretty much installed. Well, not pretty much installed. Everything is installed. I did super glue these guys down, and I've installed the negative feedback stuff on the reverse here. I've got the RD15s, or rather the fake RD15s, attached to this heatsink here. Got it all powered up. Now I do have, I'm just tapping off here for a moment. If you'll notice, this is where the low pass filters go. I haven't got them installed just yet. So I'm just tapping off here, and then that's going to this dummy load that you've seen before. So let's have a look at the waveform output on the oscilloscope of that setup. And just for Steve, I have cleaned the screen this time. Okay, so getting ready to test here. So just to go through some of the test setup, I am injecting a 700 Hertz tone. I've got it on upper sideband, and my output frequency is 14 megahertz. So let's go away and transmit that. Let me just hit run stop here so we can take a look at that, and you can see indeed I'm getting a 14.0007 megahertz signal out. That is a good looking signal there, even though I don't have the low pass filter on it. And so that's I guess the first success for the radio. Just looking at the peak to peak, it's around about 45.6 volts peak to peak, which is around about 5 watts. I have kind of been gingerly increasing the bias to the MOSFETs. So let's just check out what the current bias voltage is on those MOSFETs. Okay, so let's click it on transmit. I've got the multimeter right there. You should be able to see. So there's the bias on those MOSFETs, around about 2.8 volts. So I've been playing around with that a little bit. I mean, certainly I'm pushing the limits of my little power supply here. Let me just pan over to that, and it is actually hitting the maximum current output we have here. So you can see that little red light there. I think I'm pretty much at maximum there. There we go. Okay, so that's how I now have a look at a two-tone test. So I'm doing the usual 1900 and 700 hertz. So let's fire that away. And you can see, let me stop that so we can see that a little bit better. And you can see there, that's quite a nice clean signal that we have there. Again, there's that sort of distortion at the crossover point. Really, it should sort of come down, and there should be a clean X there. But there's a lot of things going on. As I said, I've got the fake RD15s in there, so that could have something to do with it. On the peak to peak on the two-tone test is around about 47 volts, so around about the same before there. So like I said, a little over 5 watts. So anyway, this is progress in the test. What I might do next is get those low pass filters installed, and then we can see the real signal coming out, and then we'll be able to, once we've got the low pass filters on there, we'll be able to get this thing on the air. Okay, so I have the two low pass filters installed. The one on the right-hand side is the lower end of the band. The one on the left-hand side is the higher end of the band. So these are T37.6s, and this is for 30 meters and 20 meters. And this is for 60 meters and 40 meters. And I'll be using these on 40 meters and 20 meters respectively. So pretty straightforward to wind them. For those of you interested, here's the actual circuit here, and I drew this the wrong way around. So this is in, and then here is the filter itself here, and then here are the relevant values for the filter. Let me just zoom out so you can see the whole of that. So anyway, the low pass filter is all installed. Let's have a look on the oscilloscope and see what the traces look like now. Okay, I'm testing this time at 7 megahertz, injecting a 700 hertz tone in there. So let's just see the output there. Let's just hit run stop so we can see that. So there's that single sideband tone. It's on lower sideband. So you can see the output 16.9993, which is what's to be expected, and peak to peak of around about 58 volts at 7 megahertz. The output power is quite a little bit higher. So let's do the two-tone test now. So 700 and 1900 again, just to see what that output looks like. And there you can see that. Let me just slow that down a bit so you can see that. So there it is. Again, there's you can see it's flat topping a little bit, and again, we have that sort of crossover distortion there. But all in all, a good result. I did check out on the spectrum analyzer, and there were no sort of higher order filters, so that low pass filter is doing its job. What I might do now, though, is replace the fake RD15s with the real ones, and let's see if we can see any difference between the performance of the fakes and the reals. Anyway, that's coming right up. I thought what I'd do, rather than do some more testing, is just basically get this on the air. As you can see, I did install the genuine RD15 HVF1s in the circuit there, so you notice that you don't have to cross over the leads for that. But this is all ready to go. What I'm going to do is just do some listening first, and then we'll see if we can contact someone.
Now, it's a long way for an RV to go, but the band, I can hear George. It's just I've never proven it. What I said, it didn't matter if I wanted to refund his money or not. They forced me to mail the thing. All right, thank you for frankly your problem. I give you a heads up, man. Let you know. Hey, man, I just say to keep the front porch on, man. I'm coming through there, are you? Hey, you better. I be a little leery. Those creatures are out there. That's neither here nor there. About all the comments I had lined up for this side. Fine business on the, well, I haven't said fine business essentially on the new logging program. Now that I've got Logbook of the World running here, I'm thinking it's a way to the dog. At any rate, go ahead there, Dan. You got your breakfast.
Esos calentones, ¿cómo les dicen? Pues esos calentones que van y compran ya la
We're
bolsa.
talking about 7200 early. Is that the guy that used to call himself the dog?
Kilowatt Sierra 4, Sierra Sierra. This is November Alpha 5 Yankee. Over.
November 5 Alpha Yankee, Kilo Sugar 4 Sugar Sugar. Name is John, and thank you for the comeback. We're located in southwest Florida, about 100 miles south of Tampa on the Gulf of Mexico. Next go around, we'll give you a nice signal report because you're booming in here. Is it NA5Y or is it N5AY? I think I screwed it up. Back to you, KS4SA.
You got that right. It's November Alpha 5 Yankee. The name here is Ian, India Alpha November, and I'm calling from Roanoke in Texas. Back to you.
Good, Ian. We got you 100% that time. I was writing, so I didn't look at the data. Well, we'll get to again. But fine business, Ian. We got the call right. NA5Y KS4SS returning to you. We're running the Icon 7600 into X-Beam. We are running the Icon PW1 at about 600 watts. That's what we have in this neck of the woods, and we had a beautiful, beautiful day today. So NA5Y KS4SS.
Yeah, I'm running a radio I just built and finished today. It's probably outputting around about 5 to 7 watts. You're coming in 5 and 9 here, so it's good to hear I'm getting out in Florida. It's bright and sunny in Texas. A little bit chilly, well, chilly for Texas anyway. Thank you for the QSO. What's the temperature in Florida today?
Okay, and I think I lost you, my friend. You dropped right down into the noise level there. You were running a 5 to a 6 on a meter. We're kind of nice and cool. It's not cool. A little bit in the low 80s, I would say. It beats the 90-degree temperatures we had in the summertime down here. So we kind of look forward to the cooler temperatures. Hopefully you're still getting this. So we'll send it right back to you. Won't keep it too long. It ain't 5YKS4SS.
Kilo Sugar 4, Sugar Sugar. Yeah, you're fading in and out too, but I'm hearing you pretty well. Like I said, I'm only running a 5 to 7 watt rig here, home built rig, so I'm not surprising that I'm fading out on you. We'll keep the QSO seeing as we're fading out. It's great to hear from you, and 73s for now. Kilo Sugar 4 Sugar Sugar from November Alpha 5 Yankee. 73s.